There is one major problem with sampling. It can be biased, sometimes. There are several reasons why this happens in practice. In this video, we will examine some of the most popular sampling biases. These are data mining bias, sample selection bias, look-ahead bias, and the time period bias. In general, each of these types of biases could lead to obtaining distorted information that is not representative of the population. In such cases, all inferences in the form of point and interval estimates will be compromised. So, let's start examining the data mining bias first. It consists of repeatedly using a sample data set we have at hand in order to find statistically significant patterns in the data. The problem here is that we build a model that fits perfectly the sample data, but when tested on a different sample, it doesn't work well. Here's one example. Suppose you have sales data for a firm's clients. The numbers show you how much was purchased by each client over a given period of time. And then you examine this data in parallel with 100 socioeconomic factors describing each client. In reality, you know very well that none of the 100 variables describing client profiles has any predictive power with respect to client purchases. You go ahead and test the hypothesis that a variable doesn't have predictive power for future sales levels. At a 95% confidence level, you will be able to reject 95 of the 100 variables and say that they do not have explanatory power. However, 5 of them, due to pure luck, would appear as significant predictors of sales. These variables appear as significant, but they aren't. This is because we have mined the data over and over again and introduced 100 variables in total in an effort to find 5 that have a statistically significant explanatory power. If we test with a different sample, we would see that these variables are insignificant, and we made misleading conclusions through data mining. Okay, the next type of bias we should be careful about is the sample selection bias. It occurs when we exclude a part of the observations due to data availability or some other practical issue. Examples of excluded observations could be certain assets or time periods. If you explore the returns of the companies that are part of the S&P 500 index, you would certainly fall prey to the sample selection bias, given that some of the companies will be excluded from the index at a given point in time. Firms can be excluded for different reasons: their capitalization falling under $3 billion, or due to takeovers. Nevertheless, the original sample that was to be explored becomes different. This particular instance of the sample selection bias is known as survivorship bias. The look-ahead bias isn't observed in practice as often as the other 3 biases we are considering in this video. Nevertheless, let's say a few words about it. What is the look-ahead bias? This is when we build a model that uses information that wasn't available on the test date to predict an unknown variable. As usual, an example makes understanding the term easier. Let's say that an analyst builds a model that aims to predict Tesla's stock price at the end of a given quarter, and he finds out that the best predictor for Tesla's stock price at the end of a given quarter is the company's sales in the quarter after that. So, to forecast the company's stock price in Q3, he needs to plug in Q4 data, which of course becomes available during Q4, and even later than that. Okay, perfect. The final type of sampling bias we will consider here is the time period bias. It has to do with situations when sample data is selected in a way that is time period specific. What do I mean by that? Well, imagine that you are analyzing stock returns of companies listed in the US. The time frame you have chosen for your analysis is 2008 to 2011. Do you think the data will be biased? Of course it will. It's obvious, right? This is the time frame that includes the Great Recession. Naturally, the returns of your sample would reflect the period of the global financial crisis. Therefore, it wouldn't be representative if the study was to be applied in a different context. All right, now we are familiar with 4 of the most important biases related to working with sample data and the situations when they might arise. Therefore, we should do our best to avoid these pitfalls in our future work.